SSE Group 6. I am Wu Li.
I'm Tianfang.
I'm P. I'm Chris.
I'm Yupei.
This is the final report of Security Software Engineering Group project, and we are going to introduce our electronic voting system we designed and developed for Australia Senate. The project aims to accomplish the main functions of a voting system by complying with Senate voting rules and following the software security principles. For this top-secret project, the following security requirements have been identified. First, we must ensure that all registered voters can vote, and only registered voters can vote. A voter should be able to verify his or her own vote after voting. The system must keep the voting data secret so that no unauthorized actor have the access to the votes, and no one should know which candidates or parties a certain voter voted for. It is also critical to verify the integrity of the votes data and ensure the votes are tallied correctly.
So these key design decisions follow on from our security requirements. The first is voter authentication. The current system is you need your registered name and address to be able to vote. We decided that wasn't good enough, so we've added an authentication code that gets sent out to each of the voters that they have to enter when they want to vote. And even that's not enough because those things need to be printed out, and so it's possible someone could get hold of the whole list. And so we've also made mandatory two-factor authentication part of our system. Then we need to encrypt the votes both at rest and in transit. We're using a hybrid encryption scheme, and I'll talk a bit more about that when we get to the demo. We want to have an air-gapped tally computer because we don't want the private key stored anywhere that can be read from the internet in any way. That way the integrity of the vote is ensured. And finally, we want to mandate two-factor authentication for the delegates who use the system, ideally using a physical security key, although in our prototype we couldn't do that, so we use one-time passwords.
The class diagram shows the classes in our voting system. As we can see, there are two main classes here. Class SuperDuper Server is our web server for processing the requests and interactions to and from the website and a database connection. And Class Tally System is the user interface for delegations to manage tally and decrypting voting data. Class DB connection is for the interactions between database and web server and tally system. And we also have other different classes representing different data structures, such as class voter, vote, class delegation, candidate, party, and class log.
This is a sequence diagram of voters voting. It has one actor and three objects. The actor is voter. Objects are web server, database, and the log server. When the voter wants to vote, the first step is to open the browser and enter the web server's link. After login page showed, voter uses his username and password to log in. Web server will request voter's login information and ask for one-time password. After passed all verification, voter can enter his authentication token and do the vote. Then web server will check if the vote is valid. If it's valid, web server will encrypt this vote information and send this encrypted vote to the database. After database confirms the vote stored, web server will send a log request to the log server, and log server will return a message to show log updated successfully. Finally, voter will see a notification to show that vote succeeded.
There are several user interfaces in the web system. For voter, there are two parts he can choose, the candidates in the above line part and the parties in the below line part. He could select a party by 8 button and change the preference by the up and down button, and submit the result by clicking the submit button. He could also select a candidate by 8 button and change the candidate's preference by the up and down button, and submit the result by clicking the Submit button. But once he selected the candidates, he could not select the party anymore. For delegate, he could add a new party by Add button and delete it. He could also add a new delegate by clicking Add button and selecting the party which the delegate belonged to, and he could also delete the candidate. In the web vote system, first, the voter need to log in the system by input user ID, password, and token. After logging in the system, we can see two parts, the candidates in the above line part and the parties in the below line part. We can select the candidates by clicking the Add button. Then, we can see the candidates we selected in the selected part. After we selected the candidates, we can also change the preference by the up and down button. For example, we can change Terry Keep's preference by clicking the up button. It's the same to the party part. We can select the party by clicking the Add button and change the preference by the up and down button. After we make sure the candidates we selected, we can click the Submit button and we can see the candidates we just selected. When we log in the system the second time, we can just see the result we just made, and we cannot change the result anymore. When we log in the database system, we can see the votes we just made is encrypted. As a delegate, we could log in the system by input the user ID and password. Then we could do operations for both candidates and parties. There are three columns in the party parts: party ID, party name, and delete operation. We could input a new party name and click the Add button to add a new party, and we could delete it as well. There are four columns in the candidate parts: candidate ID, candidate name, party name, and delete operation. We could input a new candidate name by selecting a party and click the Add button to add a new candidate. We could delete it as well. There are several tables in this system. For user, the fields are ID, username, user ID, password, and token. For party, the fields are ID and party name. For candidate, the fields are ID, candidate name, and party ID. For candidate, the fields are ID, candidate name, and party ID.
Now let's have a look at the functions of the tally system. A valid physical key is required to enable the system. The tally system detects the physical key automatically and only shows the login interface after the private key in the physical device is verified. This two-factor authentication is simulated by key files in our demonstration system. Once the physical key is verified, the delegate could log in with his account and password. The system will first check the validation of the input to prevent attacks such as code injection. The system queries the database to verify the input login information only if the information matches the system requirement. After the delegate logs in successfully, he will see the operation interface, which includes all the actions he is allowed to perform. The system requires the password to be changed at a required frequency. When the delegate tries to change the password, the authentication and the password validation are also checked. After the password is changed successfully, the system will require the delegate to log in again. The main functions provided to delegates include to verify, to decrypt, and to tally the votes, as well as to exclude candidates when a recount is ordered by the High Court. All the other operations must be performed after the vote data is verified.
So while the system is verifying here, I'll explain a bit about what it's actually doing behind the scenes. The vote record is a series of binary records. Inside of each one there are several fields. Here it is looking at a field that has a SHA-256 hash of the voter authentication code. Each voter has been given a unique voter authentication code to uniquely identify them. By looking at the SHA-256 hash of this, we can see everyone that's voted is actually an authorised voter. We can check whether they've voted more than once, and we can see which ones haven't voted at all, so they can get their $20 fine. We store the hash rather than the actual code, so that if someone gets read access to this file, they don't get all of the voter authentication codes. The other thing that is being looked at here, inside each record is the timestamp of this record and the timestamp of the previous record encrypted. This allows us to verify the integrity of the file. We can check that no records have been added or deleted. So this system is decrypting that verification code, which has been, as I said, encoded using public key cryptography, and then using that to decrypt the actual vote and create a bunch of vote objects from it. The other thing that's in this record is a SHA-256 hash of the verification code. And so this system allows someone who knows a verification code to give the system the hash of the verification code for indexing so that it can find the right record and return the encrypted vote to that user, who can then decrypt it using the code that they know, but only they know.
In conclusion, we have accomplished the main functions of a voting system which complies with Senate voting rules. We have followed the security principles and satisfied the security requirements at a reasonable level, with compromise to the ease of use to make a balance in between. Of course, there is still some limitation. For example, the use of the air-gapped device may lead to some security issues beyond the software level. We hope to improve the system from such aspects in the future. That's all for the presentation of the voting system by Group 6. Thanks for watching.